Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P1128, indicates a problem with the Manifold Absolute Pressure MAP sensor signal being lower than expected in the Honda Odyssey models from 2011 to 2017. The MAP sensor plays a critical role in measuring the pressure within the intake manifold, which is vital for the engine control unit, ECU, to calculate the correct air-fuel mixture. This sensor is typically located on the intake manifold, often near the throttle body, making it accessible for inspection and replacement. When the MAP sensor fails or provides inaccurate readings, it can lead to poor engine performance, higher emissions, and poor fuel economy. It is essential to address this issue promptly to maintain vehicle performance and ensure compliance with emission standards. Before beginning any troubleshooting, it's crucial to record all freeze data and any onboard snapshots, as well as review general troubleshooting information according to the Honda standards. The Manifold Absolute Pressure MAP sensor is crucial for the proper functioning of the engine management system in the Honda Odyssey. It monitors the pressure within the intake manifold, which directly influences the amount of air that enters the engine for combustion. Its accurate readings allow the engine control unit, ECU, to adjust the air-fuel mixture optimally, improving fuel efficiency and emissions control. This sensor is typically situated on or near the intake manifold, positioned closely to the throttle body for efficient access to intake manifold pressure. A malfunction or erroneous reading from this sensor can cause the ECU to miscalculate and thus negatively impact engine performance. Troubleshooting should be initiated promptly to avoid further complications arising from sustained poor performance or possible damage. When diagnosing the DTC P1128, it is essential to consider various possible causes that could lead to this issue. One of the frequent culprits is poor electrical connections, which can result from corrosion, damaged wiring, or loose terminals. These connection issues can impede the accurate transmission of the MAP sensor signal to the ECU. Additionally, a blockage in the intake air duct may hinder airflow, causing the pressure signals measured by the MAP sensor to fall below expected levels. Lastly, a faulty MAP sensor may be contributing directly to the erroneous readings. Each of these factors should be investigated thoroughly before concluding that the MAP sensor itself needs replacement. Identifying the actual cause will ensure targeted solutions and prevent unnecessary repairs. Drivers experiencing DTC P1128 may notice several symptoms indicating underlying issues. Poor engine performance is a common sign where the vehicle may hesitate or accelerate sluggishly due to incorrect air-fuel mixture calculations. Increased fuel consumption could also be observed as the ECU attempts to compensate for perceived inconsistencies within the engine's performance metrics. Additionally, a check engine light, CEL, is typically illuminated on the dashboard, serving as an alert that the vehicle's computer has detected a fault related to the MAP sensor. It is crucial for owners to be attentive to these symptoms and seek diagnostics, as early detection and resolution are key to preventing more severe engine problems. Understanding these symptoms is vital for effective communication during repair or inspection services. The first step in troubleshooting DTC P1128 involves turning the ignition switch to the on/to position. This provides power to the vehicle's electronic systems, allowing access to diagnostic functions. Using the Honda Diagnostic System, HDS, a technician must check the MAP sensor data listed in the vehicle's data stream. It's necessary to look closely at the reading, which should not be less than 54.1 kilopascal, 16.0 inch, or 406 millimeters Hg. or 1.61 volt for more than 5 seconds. If the reading falls below this threshold, it indicates that there is indeed an issue that warrants further investigation. If the values are acceptable, further diagnostic steps can proceed. Properly executing this step is critical, as it sets a baseline for evaluating the map sensor performance. After checking the map sensor data, the next action depends on the findings reported by the HDS. If the map sensor signal has been verified as being below 54.1 kilopascal or 1.61 volt, the process directs the technician to Step 7, where more intensive troubleshooting may occur. Conversely, if the values are confirmed to be within the acceptable range, the technician will proceed to Step 3. This step serves as a decision-making point in the diagnostic process, crucial for isolating the exact cause of the problem. Accurate readings from the map sensor will guide the technician to proceed with either clearing the DTC or replacing the sensor, depending on the observed symptoms and associated data. Ensuring diligence at this juncture is important to establish the legitimacy of the fault diagnosis. In Step 3, the technician is instructed to clear the DTC Diagnostic Trouble Code using the Honda Diagnostic System, HDS. Clearing the DTC effectively resets the computer system and erases the most recent codes, which can be useful for observing whether a problem is persistent. Following the DTC clearance, the engine must be started and held at an engine speed of 3,000 RPM without any load until the radiator fan engages. This procedure helps ensure that the engine management system recalibrates and can highlight any ongoing problems through real-time monitoring. If the fault continues to present itself during this phase, it provides additional confirmation to support further investigation or component replacement. Anything noted in this phase can shed light on how the system reacts post-reset and further help in diagnosing performance issues. Step 4 involves conducting a test drive under specific conditions. The technician should ensure that the engine coolant temperature, ECT sensor 1, rises above 158 degrees Fahrenheit, 70 degrees Celsius, while monitoring the engine speed to remain at 1200 RPM or above. Additionally, the vehicle should be in drive and should accelerate to a speed of 15 miles per hour, 24 kilometers per hour or more, applying no more than half throttle during this test. This controlled driving scenario helps in simulating typical driving conditions while maximizing sensor responsiveness. By executing a proper test drive, the technician can gauge engine performance and detect whether the P1128 DTC reoccurs. Following these guidelines is integral to comprehensively assessing the map system's performance and understanding how external variables affect the sensor readings. In Step 5, technicians are required to monitor the onboard diagnostics (OBD) status for DTC P1128 using the Honda Diagnostic System HDS. The main indicator to review is whether the HDS indicates a failed, demonstrating that the DTC is still present within the system after performing the previous steps. If the DTC continues to be reported, it signifies unresolved issues, leading the technician back to Step 7 for further action. Alternatively, if the HDS indicates a past status or an intermittent failure, it often reveals that the map sensor may be functioning correctly at that moment. However, further investigation should be carried out, looking for poor connections at both the map sensor and powertrain control module, PCM, to make sure they are not contributing to sporadic failures. This step ensures that thorough diagnostics are being employed to pinpoint persistent issues accurately. Step 6 instructs the technician to turn the ignition switch to the lock 0 position, effectively powering down all electronic components of the vehicle. Following this action, the next critical task is to replace the map sensor itself if previous diagnostic steps confirmed its failure. Swapping out the map sensor is a significant procedure as it directly impacts the manifold pressure readings and consequently affects engine performance and efficiency. Once replaced, it is essential to ensure that the new sensor is properly wired and connected to eliminate potential electrical faults. Proper installation must adhere to Honda specifications to guarantee that the vehicle operates correctly post-replacement. This step effectively minimizes confusion that might arise from ongoing performance issues. Final verification in the repair process requires turning the ignition switch back to the on position to power the vehicle's systems. At this point, the Powertrain Control Module, PCM, needs to be reset using the Honda Diagnostic System, HDS. Resetting the PCM clears all temporary parameters and allows the engine management system to adapt to the new MAP sensor. Following the reset, it is paramount to conduct the idle learn procedure to calibrate engine operation accurately. This procedure ensures that the ECU understands the new input from the MAP sensor and adjusts the air-fuel ratios appropriately. Proper execution during this final verification ensures that previous issues have been effectively resolved and the vehicle is operating at peak efficiency. As part of preventive maintenance for the Honda Odyssey, regular checks of the map sensor should be scheduled to identify any early signs of wear or failure. Inspecting connections and wiring associated with the map sensor can also help avoid future disruptions due to corrosion or loose connections. Additionally, ensuring that air intake ducts are free from blockage is crucial, as restricted airflow can directly impact the accuracy of the map sensor readings. Regularly cleaning or replacing air filters can also promote optimal engine performance. By implementing these preventive measures, vehicle owners can reduce the likelihood of encountering the map sensor issues that trigger DTC P1128. Consistent maintenance serves not only new component longevity, but also contributes positively to overall vehicle reliability. In summary, DTC P1128 signals a malfunction related to the map sensor in the Honda Odyssey from 2011 to 2017. A correct and thorough troubleshooting approach is vital to identify the root cause of the issue, whether it be a faulty sensor, poor connections, or airflow blockages. Each step in the troubleshooting process is integral in isolating the problem to ensure that repairs are both efficient and effective. Owners are encouraged to follow preventive maintenance practices, such as routine sensor checks and air intake inspections, to mitigate future occurrences of this DTC. Understanding and adhering to proper diagnostic protocols not only aids in immediate repairs, but also fosters long-term vehicle health and performance. Please like and subscribe to the channel. See you next time.